You are listening to the Wi-Fi Ninjas podcast, where we talk about wireless technology. Here are your hosts, Mac Daring and Matt Starling.
Hey everyone, welcome to the latest Wi-Fi Ninjas podcast. Matt and Mac here, but we have a very special guest on our show today, and his name is Neil. Hi Neil, do you want to introduce yourself?
Sure. Nice to meet you guys. Neil Salem, based out of Miami, the CEO of Nesa Solutions.
Thank you very much. Very nice to have you here. We've caught up a few times before the podcast, and we've spoken about your solution and seen it in action a couple of times, and we're very excited about it. So we thought it would be a great opportunity to get you on here so we could talk about it and show it off to some of our listeners and viewers.
Yeah, in fact, your solution was so amazing when you demoed it to us. I couldn't sleep for a week later. So thank you very much for donating your time to be on our show today. We are extremely looking forward to looking at your solution again. And especially now, it's extremely relevant to what we do, as we are in the middle of the slight RTLS push inside our company, where we want to position it more. We understand the importance of it, and the only factor that was lacking from our perspective was the business application that you guys provide. So let's jump straight in, maybe not into your application yet, but maybe into Nesa.
Yeah, and tell us a little bit more about you, Neil, as well.
Sure. So Nesa has been in business since 2008. We originally started in more of the analytical space, more from mechanical side. And then in around 2012, 2013, we got into the software side. And primarily, we started in the RTLS space because of a hospital asking us to spend $10 million pretty much on RTLS, and gave us a year to sort of find what's the best technology at that time and based on what they want to achieve. And, we looked around, we traveled throughout the United States, saw 20, 30 hospitals that are utilizing different technologies. And at the end, we came back, we said, we really don't like any of them. We'd rather build our own. And the reason for that is that we started to see high precision accuracy, high-end location solutions that really could allow us to do a lot more workflow versus just room level. So Nesa, who had no technology knowledge whatsoever, got into the technology space and built a team and began building our first application, which was called Insight, where we were able to deploy it in a few million square feet throughout a hospital system. And we learned from every aspect. One of the most important things about, being in the RTLS space is understanding every single aspect, from deploying the technology to building the software to understanding what the client wants to achieve. Those things are so separate. And yet, when you're building a platform, you really have to have all of these different stakeholders involved to really understand, because if you're doing it from an IT perspective, yeah, you'll build a really cool technology, but then the user has no clue how to use it. So we took a little different approach after the first 2 years of sort of hitting our head. And we really got the users involved to understand how they could utilize the platform. And it completely evolved our application, where today it's much more, workflow and user friendly. And so what I always say is, I sell a dot on a map with a business rule. I really don't care what dot I get. I really don't care what the map looks like. It's really about the value of the dot inside of the map. And that's where our rules engine really brings a lot of power and value.
Okay, so you started quite a long time ago, and the first experiences you had with the RTLS when you were building your platform, they were based on what? Like you mentioned, like the blue dot, you mentioned high accuracy, high precision systems back in the day. What was it? What was the go-to underlying technologies back then?
So originally when we started, we looked at Wi-Fi. We looked at Wi-Fi and IR. We looked at Wi-Fi and sonar. Those were really the three primary things. And then there was some level of RFID technology, but none of them were able to give us like accuracy. We were able to get 5-meter accuracy. If it jumped the floor, it was hard to sort of figure it out. And so we couldn't get really a good quality signal. And so the business value really didn't add value, because it's nice to know where something is, but if you can't do workflow, you couldn't really achieve what the customer's goal was. So what we started to look at in 2013 was high accuracy BLE. And BLE AOA specifically was a technology that was coming out of Finland. And it provided a dot within centimeters of accuracy several times per second. And when we saw that technology, we were like, oh, wow, we could really do a lot with it. What we joke about it is that it was from Finland, and the way it was built was said it was as a finished product. But the problem was it was built in Finland. It wasn't a finished product. So we had to really take that application and solution or platform and really massage it to make it work. And you have the lessons of learning of having to deploy a big system, thousands of tags moving around. It's not what a laboratory is. It's a lot more about, really trying to understand the technology. And it took us a few years together with that partner to really evolve the application to an enterprise application. But originally back, it was all Wi-Fi, and Wi-Fi just couldn't justify the investment. The other thing also with Wi-Fi was people assumed that the topology of the network would provide accuracy or location, and you had to add a lot more access points to get a better level of localization. The problem with that was when you had too much Wi-Fi, it caused disturbance. So we tried everything. We hit our head on a lot of things. So laboratory versus real world, specifically in the healthcare space, so different.
Yeah, and also there's still people today that think that an RTLS Wi-Fi solution will work. We were talking to a friend just last night actually about a hospital that's designing an RTLS solution trying to use Wi-Fi. So we had an interesting conversation about it then. So people are now still trying to design and implement a Wi-Fi RTLS solution.
Not only that, Matt. Last week I was like advising my friend that is working with a massive museum in central London, and they are planning to do the RTLS deployment in and out with Wi-Fi as well. So it's probably not the best idea, right, Neil?
There's no technology that's a silver bullet, and it always goes back to sort of understanding the business goal. Instead of selling the hardware first, understand the business goal of the client, and then you could define the technology second. Today, we have the availability of BLE, ultra wideband, even computer vision from cameras that can provide high precision location. So depending on what the client wants to achieve, you really have to understand first what they want to get out of it. So if they just want to know that somebody's in an area, yeah, you could do Wi-Fi. But if somebody wants to follow a pathway pretty accurately, you got to define the technology that they want. So Wi-Fi will improve. It will get better. I think that the big companies like Cisco, Mist, Aruba are all improving their accuracy or their algorithms based on what they see from the BLE and the ultra wideband space. And then they're going to basically converge it. So depending on the topology and depending on what the client wants to achieve, there will be some Wi-Fi. It's just not as granular, as I would say, as other technologies are from that perspective.
Yeah, I can't agree. More than I do. Absolutely spotless. So the issues with the clients that we worked with, you with your friend and me with my friend, they didn't have a use case. Okay, so they just heard RTLS somewhere and they wanted to have it, but didn't know why. Probably that's why they were trying to dive too deep into something that probably is not going to work for them too well.
Yeah, a lot of people talk the word RTLS, and I actually hate the word RTLS because in the United States, and specifically in the healthcare space, it's a failed technology. They spend millions of dollars putting this technology in. It never works. And it never works for multiple reasons. One, the batteries are dying in the tags. The location is jumping from room to room to room. So the data that's coming out of it's not very accurate.
Or floor to floor, you see some clients turning into Superman and just, from ground floor all the way up to the 8th floor and then maybe back down to the 4th floor.
Yeah, we've seen that with atriums, jumping by floors.
Elevators end up doing a lot of negative. So anytime they put an access point near an elevator, it always causes some level of that. But I always say, go to the client and ask the client, what do you want to achieve? Don't give us an RFP or a proposal saying we want to have location. What do you want to achieve? So RTLS is a hard word. That's why I always say we're in the location tracking technology space, or location intelligence, or advanced location these days, because you could do so much more today than you did 10 years ago. But the technology is only one part. It's the software that allows the client to really achieve the business cases. So we always go back first, business goal, technology, second or third in the totem pole.
Yeah, absolutely. So as you mentioned before, because this is not the first time we have a chat, we can achieve a very good and accurate blue dot XY coordinates on a map. It's not a challenge anymore. So depending on the environment and depending on the requirements and on a use case, sometimes room accuracy is good enough. Sometimes sub-room accuracy is good enough. Sometimes just locating at, I don't know, like an exit point, choke point is good enough. And sometimes we require precise, accurate, and fast locating. And also the environments that the RTLS system or advanced location system, because we don't like RTLS anymore, operates in might change our minds when it comes to choosing the right RTLS solution, right? Like underlying technology, something that works in the carpeted office might not work in a warehouse or in any industrial environment, right? So that's probably another factor. So what you guys are doing, as far as we know, is you don't care about the underlying technology too much. You just take the XY coordinates from whatever system the client is using, and you convert this information about the location of assets into actions, into business intelligence. So you just take the location and do whatever you want to do with it. You can trigger an alarm, you can trigger an action, you can send an email, turn on the light, turn off the aircon, whatever, right? So let's just maybe spend a few minutes about your approach on this, your take on it.
Sure. So you actually explained it perfectly. So I'll just say the same thing, but I don't think we need to talk about the technology anymore. Can we get an accurate dot? Absolutely. Is it centimeter level? Absolutely. Depending on the area that you're doing your deployment, you could get, from a BLE perspective and an ultra wideband perspective, precision accuracy. And you define which technology you're going to install based on your surroundings. So I really hate to talk more about can we prove the technology? It's proven. We've seen it. It works. The most important thing about any software that takes that data, by the way, is when you're talking about a lot of tags, tens of thousands of tags, you have to be able to have an application that can ingest that data. So, now that we know that the technology works and there's abundance of technology, what Nesa recognized was we can't be attached to one hardware platform, one positioning solution. And around in 2018, we made a decision for the company that we're going to be agnostic to technology. And for the reason that is that you don't want to go into a client that already has a positioning system and say, sorry, rip it out. You want to be able to absorb and ingest that data so that they don't look bad by spending several millions of dollars. And then for our application, a dot on the map could be any technology. In our office right now, we have several ultra widebands, a few BLEs, few Wi-Fi location, and all of the dots on our map look the same. So we work with Suio from an ultra wideband perspective. We work with Coupa from a BLE AOA perspective. We work with HID from a BLE beaconing perspective. And some legacy technologies that we work with already that are Wi-Fi based. And to be honest with you, either we position the dot on the map by an X, Y, Z, or we receive a room level knowledge, like, tag 101 associated to Neil is in room 101, Neil's office as an example. So depending on how the technology sends us the data, I always like to use the word ingested. I think like our application's like a funnel. We could take as many different technologies at the exact same time, but it goes through that little small spout, and then we show the dot on the map.
Okay.
And so,
yeah, if you don't mind. So you take the location data calculated by the location engine of the solution that is already deployed, right? So if you have Kappa or Savio, they give you XY coordinates of an asset with certain frequency, and you just take this data, plot it on the map, and make it actionable based on where the dot is. How about like vendors like, I don't know, like Meraki, let's say, Cisco Meraki. They are Wi-Fi or BLE based. They have both. And their default XY coordinates that they calculate is based on trilateration using multiple APs. And sometimes you just don't have this, enough number of APs for this data to be accurate, to the point where you have like 20 meters inaccuracy in the location calculated by the system. So this is really off the charts because they are using at least 3 APs and more to calculate that, and it's wrong. Okay, you would probably prefer to just use a cell of origin, like which access point the client associated with, to get this information plotted onto your map to make it more accurate, instead of trying to trilaterate the location of a client without having enough number of access points. So my question is, I know that you can take the location data from a system pre-calculated by a location engine, but can you, let's say, plot a data like AP association using API from a vendor like Meraki, in case they have no RTLS design and it's just like, one access point per room, maybe with high attenuation of the walls, where the calculated XY coordinates would be very off the chart?
Yeah, so the answer is yes and no, and I'll give you the long and the short. There's enough companies that are providing positioning solutions. That's their job. Their job is to provide where the dot is. When we started the business back in the day in 2013, 2014, we were always told this word covariance metrics. You got to figure out the covariance metrics of where the dot actually is based on the potential of where it could be. And we spent 2-3 years with our engineers and our developers putting in all these filters and common filters and all these things. And then I made a decision. I said, no more. The business of the positioning solutions must provide Nesa where the dot is. That's it. And the reason we say that is that there's no, like, you stick your finger up in the air and say like, oh, it's potentially over here. No, you have to get some level. So when you talk about like a Meraki system that's sending out a level of where the dot is, it's going through their positioning application. If we're looking at it from an RSSI, where is the signal strength of the tag versus the beacon? Yeah, you could figure it out, because the beacons. You could associate some level of intelligence and learning, so that all the time that you get a 67, RSSI value, that it's beside this beacon in this room, you could do some level. But I could tell you that we don't want to get into the space of the positioning engine solution companies. That's their job. At the beginning, everybody that started this, especially in the BLE and even in the ultra wideband, we were their guinea pigs. 2012, 2013. We were absolutely their guinea pigs. We were so gung-ho about the technology of this level of accuracy, but we had no clue what we were getting ourselves into. It only took 2 to 3 years till we realized that's not our business. So when we work with customers or vendors now that are providing a solution, we actually have a very good office lab, as I would say. We have multiple technologies running simultaneously. And we could tell the vendor of the hardware, your application's working, it's pretty accurate, or this is the issues that you're having. So I go back to the answers. The positioning companies need to provide the proper positioning, the topology, the installation, the output of data. That's on them. And you, as me, Nesa as a company, can't do all in that perspective. So we really try to give guidance, but it falls on the hardware companies.
Understandable.
So what are some of the ways that you at Nesa then extrapolate that data from, say, Mist or Sebio? How do you get that data from the vendor and then produce that information in your system?
Sure. So most of the positioning engines actually sit on premise. A few of them now are sitting in the cloud. But ideally what we do is we have what's called a wide receiver, an adapter that sits right after the location positioning engine that's on premise. We take that data, we filter that data on the spot, and then we send up the data to the cloud. And one of the things that we learned to do is to compress that data and also throw out some of the data that's not important. And so, our application just sits literally right behind the positioning engine in a VM application.
Okay, and you mentioned that you're in Miami yourself. Is that where Nesa is based as well?
Yeah,
Yeah.
I'm originally Canadian, but it was too cold.
Yeah.
So moved down to Miami, which is a lot warmer and sunny. And yeah, so Miami's headquarters is in Miami, and, literally in Miami. And we've been here in our place 9 years already.
Amazing. So your solution will work quite comfortably then in the US. How about if I was a customer in the UK or in Europe and I wanted to leverage your platform? Am I able to, install your adapter and then leverage your cloud? Or how does it work? Is there any issues with that? Do you have kind of multiple cloud sites across
Yeah.
the globe? Yeah.
Yeah, we're agnostic to any country. So there's two ways about doing it. From a Europe perspective, if you want to meet GDPR, we actually just put an instance in AWS in any of the countries. We have deployments in the United States. We have deployments in Canada. We have deployments in Australia and New Zealand. We have deployments in Germany. We have a very big partner of Lufthansa Industrial Solutions, which represents our product throughout multiple industries. And we have a deployment in Ireland. So it's, this is an application that works anywhere. The application's in 10 languages already. So it's pretty universal. It's very easy for us to deploy. All we need is a map and access to the location. And we install our adapter on premise, and all the data then feeds up to the cloud.
Your adapter, can we just talk about that more? Like, what is that? Is it a small little appliance? Is it a VM? Like, what is your adapter?
Yeah, we call it an adapter. We call it a wide receiver. It's literally an appliance that sits in VM, just a piece of code, to be honest with you, that just collects all the data.
No physical hardware then?
No, we don't. We have done installations completely remote, never sending. The only hardware that you need is the positioning hardware. Beside that, everything else is just all VM.
Okay, so the adapter, it's just like a middleware really that gets the positioning data from any vendor and compresses it, translates it to your I don't know, syntax, and send it to the cloud for your application to work with. Is that it? That's it?
That's pretty much it. And we have adapters for so we have different adapters for the different hardware. So you may have 2 to 3 different technologies running in your facility. So we would install the different adapters based on the hardware. And yet, correct, we gather the data, we receive the data, and then we push the data up into the cloud.
So by the technology, it's like when you have Sevio, they will have their RTLS studio providing your adapter with XY or XYZ coordinates. You use that, compress that, send it to the cloud. If the same facility also has like, I don't know, passive RFID, they will have some information that will be in a slightly different format, maybe to what Sevio would be sending. You have another adapter for that. You convert it to the same type syntax of data, send it to the cloud. That's it?
You got it. You're dead on.
Okay.
And just to give you, each one of the companies has a different format, so it's not similar. So we actually have to build an adapter specific to each one of those.
Okay, and if you have companies that just work in the cloud, like I don't know, Mist, where do you position an adapter?
Yeah, so we just pull the data. So we actually pull the data from their Kinesis stream. So it's the same way as that their positioning data is in the cloud. And then we pull that data from their AWS Kinesis stream. No different than having the adapter on premise. We just happen to have it in the cloud in that perspective.
Okay. Yeah. Easy, simple.
Yeah.
So you just need an adapter. You just need a floor plan. And then the same floor plan probably must be used by the location engine, right? So
correct.
You need the same exact floor plans as the XY coordinates. Typically, they are calculated from, I don't know, like a bottom left or a top left corner of the floor map, and that's it.
So we call it a 0-0. So so if you want to look at how most of the applications work, is that from the hardware perspective, they have the hardware company that provides a location has their own internal module. We'll call it their positioning engine. You install a map. Most of the time, it's like a PDF view or an SVG file, or even a PNG file, excuse me, that will have the image. And then they basically put it on a plotter. From that perspective, where they'll make sure that the map is properly scaled. Once that's done, they're going to have where they know where their dot is in that map. we take that similar map or that same map, we convert it into our format. We utilize a DWG or a DFX file, which is an AutoCAD file. The reason for that is the scalability is much better. You have much more granularity. So we have a whole mapping conversion tool. Additionally to that, we also use some newer technology that we're going to coming out with, more 2.5D, 3D. The reason for that is that, digital twin, RTLS is now considered digital twin, as I would say. Once you have that map, we take that map, we put it on the proper grid. Once we receive that positioning data, we're exposing that dot exactly where the dot's supposed to be.
I just had two questions regarding around the maps. You saying you need to have the same map that's installed on the location engine software, Miss Sevio, whoever. That needs to be the same map as you load into your Nesa applications. Does that mean you've got to have the exact same scale as well? So say if you scaled, 10 meters on the Miss system, does it need to be, say, the same 10 meters on?
1-to-1. It has to be 1-to-1. Now, as if it's the same map, it could be a different file. On a positioning engine, it could be a PNG file, and they could send the client, they'll send us a DWG file, but the scale has to be the same. The biggest problem that we've ever seen in deployments is the maps are always wrong. Physically, the client will send you the map, and you will put it in per scale, and your dot is 10 feet over, and you're spending 3 days trying to figure out why. And then one day you look back at the map, and you're like, look, the map's off by, 3 inches, but 3 inches times 200 feet ends up being 10 feet. So the map is so important that it's accurate.
Yeah, also as well, actually making sure from the physical perspective as well, that you don't get sent maps that are 10, 15 years out of date and they've knocked down a whole bunch of walls, and it's, the client's like, hey, I'm not walking through that place, but to you, it looks like on your system, it probably looks like they're walking through walls now, but it's all open plan because they've decided to knock some walls out.
Yeah, it's always been an issue. What we've seen in the healthcare space is that there's a lot of turnover of personnel. So you get this map, they send you, this is the most accurate map. Then you do a walkthrough, on-site walkthrough. And, we like to walk through the locations just to get an understanding, because ceiling height is important. Where you're placing the beacons are important. You never want to, when you get a floor plan, you want to put a topology down. You don't know what's on the ceiling. You don't know if there's, speakers. You don't know if there's exit signs. So you actually have to fight for the ceiling space when you're putting your deployment and your network down. But maps are really important to get from the client that's accurate. The other thing that's essential is what we call a nomenclature. How do you name your rooms? Is there a standard? Because you may call a room 101 7 times. So when your positioning engine is sending out the data, it's saying 101, but where? So we work with our clients to really understand the nomenclature. What's their strategy? Because it's not just one building. It could be 10 buildings in a campus and have 10 floors per building. And you're having a distinct location. Every room is unique ID. And you have to be able to correlate the data to that unique ID to expose the dot on the map. So maps usually end up being the biggest pain. The nomenclature, you'll always see mistakes. They'll always call the rooms similar names. In our application, what we did is we actually have a nomenclature, what their standard may be, and a nickname, what they call the room. Because some people don't actually call room 1773, they'll call it OR1, or they'll call it laundry room, or they'll call it, prisoner cell 1. So we have the ability to have, nicknames associated to that.
Nice. And it's actually quite smart what your guys doing, that you are taking the maps, you are vectorizing it, making sure that you have the same resolution of your maps, which is no longer resolution, it's vectors now, but you can have as much granularity as you want, because one vendor can have a pixel size of something different than the other vendor that is just room accuracy. They might have just extremely different grid sizes, and making sure that it's all standardized.
Yeah, and the other value, just to add to that, is that if you convert the data into a DFX file, you could actually have the room information already geofenced. So instead of having to draw out thousands of geofences and name each room, you could pull that data from a DWG file. So there's a lot of value proposition besides just being able to scale. The other thing is, if you have a high precision accurate location system that's sending a dot that's pretty accurate, we could build business rules in very small areas. You could build geofences 2 feet by 2 feet if you have that level of accuracy. whereas other maps you can't. So you could only do room level. So, scalability is one thing, but being able to achieve the business cases that the client wants to utilize is the second value.
And that's a very important thing that you've just mentioned there, because we've seen deployments with a solution that we've tested fully and agreed that it has 22 meters accuracy at 90% of cases, let's say, all right? So very crappy accuracy. And then the client wanted to have like zones of, 4 by 4 meters, 5 by 5 meters, and they were scratching their head thinking, why it's not working? Why do I see more people in the zone that I know that there is no one there? So the zone sizes that you use for your business rules, they must be relevant to the corresponding accuracy and precision of the RTLS system that is being used.
And we have what we call cluster view. And so the idea is that if you don't have precision accuracy, instead of seeing a dot moving around almost perfectly, you actually just going to expose how many dots are inside of a clustered area. And when you build out your cluster size, you're going to first know the quality of the signal. You're going to do some testing. So based on that, you could build out any size of the cluster that you want. And the other thing about when you're building out cluster or zones, you got to give a gap between each zone. Tags float. And that's why in our business rules engine, we have a delay, like a time delay, because we know that tags jump or float depending on the technology, but no RF signal is standing still unless it's in sleep mode. And if it's in sleep mode, it's just sending a heartbeat that it's still in that same position. So depending on the technology that you end up deploying, you build your workflows or your zones after.
Okay. So that will be applicable even for like sports. You still have to have this buffer.
Yes. Yeah. So if you watch sports, again, if you watch any RF technology, the tag will float. I mean, if you just walk in front of a tag, the tag will jump because your body mass is water. Depending on where you place the tag, the worst place to ever place a tag is on your chest. That's always a joke. I always watch all these videos and I see people walking around and they're placing on their chest. Best place is always
have massive feet, right?
Yeah.
And worse.
Yeah, and especially for me that I'm a little fatter than I used to be. The signal absorbs a lot worse.
Don't worry. It's a lockdown effect. It just doesn't affect Matt, but everyone else.
Yeah.
Okay, so we were discussing the precision locating and how you get the data XY coordinates to deploy your business rules inside Nesa application. So that's fine. Can you do something else than just precision locating, like maybe locating by association and getting rules around that? Like what happens if tag A comes into close proximity of tag B and this kind of stuff?
So our rules engine is what I call, condition and actions. And so let me just go back a little. When we talk about tags, I actually consider it as connected devices. A connected device could be an IoT device, a sensor device. It could be a tag. It could be a multitude of different things. So our application actually absorbs all different, sensor data, IoT data, tag data, and our rules engine really tries to convert all of that into an outcome. So, simple ways is tag enters a zone, tag leaves a zone, tag is beside another tag. Tag is a tag count, how many inside of a zone. Tag status, which is something new that we just added. I'll explain a little more. And IoT data, above and below certain values and perspective. But in our application, the object is a source of truth. That object is a person or an asset that you associate a tag to. And in our application also, we could associate multiple tags. So if you're going from building to building, location to location, you could have a BLE tag or a ultra wideband tag or a Wi-Fi tag, and also associate it to a GPS tag, so we could see it throughout the chain. But the rules engine is really about what do you want to do? If tag enters zone, okay, what zone? You select the zone, and what do you want the action to be? Do you want to log the event? Do you want to send turn on a camera? Do you want to have the tag beep, buzz? Do you want to color the map, the room a different color? And it's not just one thing, because that's just one event. What we did is we built almost like a tree or a branch strategy perspective on that, where a tag enter zone, if it goes left, it does this. If it goes right, it does that. If you enter a room and the temperature is 72 degrees, then this occurs. If it's 71 degrees, then that occurs. And that's the reason for that, is that every workflow that a client wants to do is primarily a dot entering a zone and a dot leaving a zone. But the way that they want to use it is their own use case, their own actions, their own outcomes that they want. You know, in healthcare, we call baby abduction. Baby abduction is as simple as dot gets to a zone and it sends a trigger to lock the door, turn on a siren, and notify. Well, all those are just actions. So we recognized back in the day that we have to build a rules engine that any client for any business case could build their own outcome. Because when you sell the application to your client the first time, you say to them very simply, what do you want to achieve with the dot in motion? Oh, in my situation, I have a forklift that moves around the factory and I want to know when it associates to a pallet. Okay, well, to us, that's contact tracing. It's two dots get within a distance of each other for a period of time. We log that event, and then an outcome when they break apart occurs. So 99% of all of location workflows are simply dots entering or dots leaving or dots connecting in that perspective. That's why I always say we don't care about what the dot is. We don't care what the map looks like. It's all about the business rule.
Yeah, but the thing is that you have to have this map, right? So you need to have the XY coordinates to be able to say that two tags are close to one another, to trigger an alert when they're probably, I don't know, getting apart, when someone is stealing the baby, or if someone else is holding the baby while trying to leave the building, whereas probably mom is not around anymore. That's what would trigger an alarm. So you wouldn't be able to say, like, if a baby is getting farther away from a mom without knowing where the baby or the mom is, you wouldn't be able to do that, right? You require XY coordinates and you require a map.
Yeah, so yes and no on that one also, because now with computer vision, you could have a little more intelligence and advantage. But yes, if you're not tagging the object, it's blind. I mean, I can't state that in a greater way. But when we talk about the map, there are technologies in the ultra wideband space, because in BLE, contact tracing doesn't work. It won't work at a level of two phones seeing each other within distance and basically knowing that you're 6 feet. The accuracy is just not there, and the ranging's not there. But in ultra wideband, there are some things that we've done where we could have two tags communicate with each other. They see each other, they log the event, and based on where you place the beacon in the ceiling, either the data gets uploaded at the end of the day, or if you have enough beacons in the ceiling, you could actually know what zone it occurs in. So there are ways to be blind, as I would say, and not have it on the map. But again, it depends on the business requirement that the client wants to achieve.
Okay. And another very interesting point you've raised about the computer vision. So when you have a computer vision, so normally it will track assets that are not tagged, right? So the number, like, I don't know, like a heat signatures or face recognition. Do you have any way of tracking that inside your system?
Yeah, so actually that's really where I think the future of the technology is moving. I think it's a convergence of using a multitude of technologies, a high precision location system, and cameras. The reason for that is the pain of the RF world is that you have to tag everything. The value of a camera is that you could associate by taking the object and then associating a picture to it or an image to it, and then the camera could pick it up and know it is. So in my office, I have a bunch of cameras. And every morning I walk in and it sees my face and it knows me. And I get a text message that says, welcome, Neil, you're in room 101, because the camera is in room 101. So we could do the association. I think that where we're going to see the real value of location tracking systems is that utilizing the union between an RF high precision technology or a low precision, depending on what the client wants to achieve, and some level of cameras. And if you could, because we built the object that we could have multiple inputs, the camera becomes an input or a tag almost in that perspective. So we are working with a company called Hanwha, a pretty large company, where we are building for a healthcare space what we call telesitting. is basically a camera monitoring a patient that it falls off the bed. And we're using pose analysis, we're using facial recognition, and then we're correlating that data with the tag that's associated to the room. And so that's really where we, Nesa, believe the future is that most people already have installed cameras. So you're just applying an intelligence on top of that if the camera has that kind of quality of video. And depending on the hardware that the client ends up having, you could start using both. So that's where 2021 for Nesa is really focusing on, is that the camera stuff. And I think that it's going to be the future, in my opinion.
And you mentioned that Nesa is like an application that runs in the cloud. If I am a client and I want to view that data, how do I access your application? Do I just have to go to a web browser, or do I go to a iOS or Android app? Like, how does it work?
So our applications in the cloud, you log in, through a secure, URL, and you log in. We actually use two applications, our options to log in. We use either Okta or Keycloak, so it's at the high level of access control in that perspective. And then our application obviously is viewed on any platform, any mobile platform. And from a web perspective or a mobile perspective, our application is built in responsive, so it can be seen and utilized in any mobile device. We're not going to be building any native platforms anymore. We did that in the past. We had an Android and an iOS application, and the effort and the constant changes just caused too many headaches. So, today we could run everything in responsive.
Okay, so Neil, how does it work when you have a person entering a room and your camera sees it and this video feed is being fed to your system? How do you know who that person is? Do you care? Do you want to be able to, I don't know, correlate a tag that this person is wearing with a camera vision, or maybe there is no tags whatsoever? How does it work? Do you calculate it as Nesa?
Yes, actually we do. So there's two ways to do it. In our application, we have the object. The object is the person or the asset, as we hope. So in the object's information, we could associate an image to it. In that perspective, that image is now in the database of the object. And if it's obviously unique, my face is pretty unique these days. It will, when the camera picks me up, it will actually look and say, it's Neil Salem, as a perspective on that. The other thing also is that if your person is tagged, so if I have a tag on me and I walk into the room and it says, Neil Salem's tag is in, and then it sees in my face and it's not me, it'll actually come back and say, this tag is assigned to Neil Salem, but is not Neil Salem, based on the fact that I have red hair and I look completely different. So we're looking and we're building those associations on that perspective, in that way.
Okay, so we not only take XY coordinates from your, I don't know, partners, vendors, whatever we call that. You also can take the video feed of a vendor, of any vendor. How does that work? If I have my, I don't know, like a webcam or the camera that I'm using now, can you use that feed to identify me entering my room?
So I don't have the answer on that yet, because I really don't know. We're only focusing on one hardware right now, which we partner with Hanwha, so we're testing their cameras. Although we've built our own video, our media server, as we call it, or a VMS, and then we've applied our own computer vision or data analytics tool to it. So Nesa ended up hiring two engineers specializing in computer vision, because there's so much you could do with it. And, we're just scratching the top on it in that perspective. But for us, from a location perspective, you just want to do either the association that the person that's tagged is actually that person, or the fact that, you go around a bend and you see that person. I think computer vision is going to, in my opinion, depending on how much cameras are installed, will end up being one of the top location tracking solutions in the future.
Yeah, and it makes sense. Even if you have a tagged person or an asset and it's a little bit off, something is, I don't know, like a few meters away from where the person is, with the computer vision, you will be able to correct that, perhaps.
Yeah, it doesn't lie. I mean, that's the thing about cameras, is that, in the RF world, we're not knowing exactly where that person is. I mean, we're just getting a coordinate. We're figuring out that coordinate and we're plotting it on I always like to use like the example of battleship. You know, you're on A1, B7, C6. That's location tracking, because our map is a grid underneath it, and then we're correlating the dot to where it is on the grid and going in motion. With the camera, it knows exactly where you are because it has eyes. And so what we're now doing is taking those two data points and meshing them together, as I would say, and then providing that as sort of the source of truth.
And if you don't want to attach a face to a person that you're tracking, is that possible? Maybe to just count the number of people and use it for occupancy statistics throughout the facility?
Yeah, there's a lot of applications already out there that have cameras that are doing heat signatures, or they're doing, counting in that perspective. It's not really our business yet, as I would say. We've always focused more on the RF side, but we are looking at how other companies are using cameras. But again, for us, I think we're trying to do it a little different in that perspective, because you could validate with cameras certain workflows, like in hand hygiene in healthcare, you have to wash your hand. So if you use high level precision accuracy, you could walk in. If you walk into a patient room, you could change the patient status, the doctor status from dirty to clean, as an example. If he walks to the dispenser and he taps the dispenser with an IoT device, it will validate that the guy was within, a foot of the dispenser. The dispenser moved. It verifies it, and then he proved he washed his hands, as an example. That's all based on data, blind data. If you add a camera, now not only could you see the person walk to the dispenser, you could validate by video that he made a motion, and by that motion, you could validate that he washed your hands. So cameras become eyes for workflow versus just tracking or watching somebody come in.
So we have the eyes in form of the cameras. We have the ears in form of the RF energy. How about the nose? Can we pick up a smelly guy coming into our office, making sure that the doors automatically lock so he cannot come in? Can we do that?
So yeah, if you have a sensor that could smell like rotten eggs and that trigger an event, then the answer on that is yes, because our application has what we call an MQTT broker, where it could receive any of the IoT data. So if the IoT data is coming in and it goes through our rules engine, which it does now, it will say if IoT device senses this above and below a certain value or parameter, then the action is to send an API to the door locking mechanism to lock down the door.
Amazing.
Yeah. So
wouldn't be good for you though, Matt, because you wouldn't be able to get into any offices anymore.
Or you? I heard that the vegans' farts, they're the worst in the world.
Yeah, I'm not a vegan. I eat sushi and steak. So.
Yeah, unlucky Mac. I think you're the smelliest one here, so you probably wouldn't be allowed in.
I'm gonna stay out of this one.
Okay, well, I think that's probably. Is there anything else that you wanted to mention or cover today, Neil? Like, I think it'd be good if you could let people know how they could get in touch if they want to find out more about you, about Nesa, and then we'll save the demo and like dive into your platform and the application and that for another session.
Sure. So going back to this conversation, the value of location. We've already proven the technology works. There's a multitude of different companies that provide high level accuracy, low level accuracy, all depending on what the client wants to achieve. You always got to focus on the business. What does the client want to achieve? It's not about any industry anymore, because a map could be a map, a dot could be a dot. It's all about what the client wants to achieve with the data. We're in the world of data. We're sending reporting. We're providing all of this information, but we're also providing the instant reaction based on what something occurs. If somebody enters a room and he smells, then do that. That's the value of where location is going. And instead of selling modules, our philosophy is we give a rules engine that allows you to really just do anything you want, as simple or as complex as possible. We're enjoying this space. I'm fortunate, I started Nesa 10 years ago. I've never worked a day in the last 10 years. It's a blast to see this industry finally evolve. I joke that COVID is like Tinder for our industry, where, everybody's now looking at it. one word says COVID, the next word says, contact tracing. Contact tracing is 2 dots within a certain range, and you're logging the event. So I think that finally, as bad as COVID has been for the world, it's been phenomenal for our industry because it brings the value. It shows that the technology that we all focused on for so many years, trying to prove, hey, look what we could do with it, has now been where, it's sort of almost accepted and it's expected to be embedded into sort of the fabric of the future. And so companies like Nesa, we have to look at what's next and not just accept what is available today. We have to see how we're going to converge a lot of different technologies so that any industry could use it. The other important thing about, today is that people are trying to find solutions today for a problem today. But when you install an infrastructure like, location tracking technologies, you should be able to use it for everything. And people have to be really strategic on why they're making this investment. One, when you have a problem, you try to solve an issue on the spot. But when you have an application like this, you could do anything with it. It's like Wi-Fi. When Wi-Fi was first installed, you had a single use for it or a second use for it. Today, it's expected. And I think that our industry is exactly where it is. But why Nesa focused on the software versus focusing so much on the hardware is because we realized the gap in the market has always been that business application. So, we're excited. I love what I do. I have an awesome team, real good value, knowledgeable people that have different skill sets, but it's all about the real world. And when you go into this space, you have to ask the client, what do you want to achieve? Not, I want RTLS. What do you want to achieve with this technology? Because that sets a stage for exactly how you're going to do the deployment, which technology you're going to choose, and what the outcome the client's going to expect. So I look forward to the future. I look forward to demoing the application and showing you real world examples of how the applications could work. But I'm just proud to be in an environment where we see the trend growing rapidly. And speaking to you guys, I mean, it's been really cool to speak to you guys, show you our platform, and just grow the industry. And we're not in we're in a global economy now. We're not a company that's in Miami that could focus only on Miami or in the United States. Our application works anywhere. And that's what's exciting about the future for Nesa.
Yeah, and it's really amazing, man, to have you here on our podcast today. So you just mentioned that you can do like a simple things or more complex things with your application. That's another differentiator, because most of the applications that we worked with, it was what happens if you enter zone A. And then you can either open a website or trigger a notification on the smartphone, but you don't have the ability to do multiple actions or have multiple conditions to trigger this action. And that's, I feel what gives you this power to do whatever you want with the Nesa application in any vertical, and just, be super robust and powerful, because you can do if, then, if you want to. And that's a novelty, which is great to have.
Pretty much, yeah.
Yeah. So yeah, we were waiting for the application like yours, really. So when we first spoke a few weeks back, we were extremely impressed with what you can do, and therefore we've decided to dig deeper and have these conversations and have more of these conversations with you, Neil, because we just believe that what you do is right for the industry.
Thanks. For us, it's just been fun, and it's seeing the evolution of the technologies and really understanding them. It's one thing to play with it. It's really, the second thing is to really understand how to use it. So we're excited to show you guys the value propositions. And remember, every industry is based on location. Every workflow is based on location. So as long as you actually apply the technology the proper way, you could do so many things with it. So instead of being reactive, you're proactive. And that's the value proposition of the location intelligence space.
Yeah, exactly. So I'm really looking forward, I think both of us are, to the next episode, where we will spend entire hour-ish looking at your platform, looking at the real use cases, what it can solve. Because what is the purpose of the RTLS? To increase safety, save time, and save money, pretty much, right? In one sentence. Did I miss something?
Improve efficiency. I mean, I think at the end of the day, safety and security is one thing, but you're applying a multitude of different technologies that could really improve efficiency, and that saves you money, and that reduces your risk
and time. So we will see exactly how to do that in a few weeks, I think. So thank you very much, Neil, for your time. Thanks, Matt, and I bid you a very nice evening, guys.
Yes, thank you very much, Neil. Looking forward to it. Cheers, guys.
Pleasure.